Okay, so I just want to do an example. So we want to find the divergence of the gradient. And we want to find the curl of the gradient of a certain vector field. So let me come up here and first tell you what the gradient is. Let's compute the gradient. The gradient of x, y, z. Okay, so the first component is going to be the x derivative. That's yz. The second component is going to be the y derivative. That's xz. And the final component is going to be the z derivative. That's xy. And so the divergence is going to be the gradient now dotted with this vector field, yz, xz, xy. And what is this? Well, it's going to be the derivative of the first component with respect to x, which is 0. So let me just write out what this is. Okay, and observe what happens here. The x derivative of yz is 0, the y derivative of xz is 0, and the z derivative of xy is 0. So overall, this is just equal to 0. Okay, and now let's compute the curl. So I'll do this in a different color. So this is I, j, k. This is the x derivative, and this is the y derivative. Now, I didn't say it explicitly before or at all, but since this is the cross product, it's important that this row, in this row, you put the differential operators, and then in the third row, you put the components. If you do it backwards, you're not going to get the right answer because the cross product is not commutative. Okay, so the first component is going to be the derivative of the 2x2 matrix, the one that's in like the bottom right. So it's going to be the y derivative of xy minus the z derivative of xz. So the y derivative of xy is x. The z derivative of xz is x. Okay, of course that'll be 0. Now the second component, minus, is going to be the determinant formed by the outer two columns. So it's going to be the x derivative of xy, which is y, minus the z derivative of yz, which is also y, and that component is 0. And then finally, the third component is going to be the derivative of this 2x2 matrix. So this is going to be the x derivative of xz, which is z, minus the y derivative of yz, which is also z. And so this is equal to the 0 vector. Or we can write it something like this. Okay, so the divergence of this is equal to 0, and the curl of this vector field is also equal to 0. Now, the reason for that, so this one, the curl, this is not a coincidence. We'll look at some of these identities as we go down below. The curl is not a coincidence, as we'll see, and the blue is not, is also, but the blue is a coincidence. So the blue, this blue problem, the problem that we did in blue, the divergence of a gradient is related to something called the Laplacian and harmonic functions. And something similar is true, and we'll look at some identity that relates to the curl of the gradient, of a gradient field.